let us now study about limitations of Ohm's law. Even though Ohm's law is very useful, but Ohm's law is not always useful for every devices. So let us look at its limitations. There are many limitations of Ohm's law. What is mentioned here is just few of its limitations. The first limitation is Ohm's law is strictly applicable for metallic conductors only. That is because only in metallic conductors Ohm's law is valid, and those devices are called as ohmic devices, which means in those devices a graph of voltage versus current would be a straight line like this. So it is true only for metallic conductors. Second point is very important. It says that temperature and other physical conditions should not change during the passage of the current. This is because if we recall the statement of Ohm's law, it was stated there that with temperature and other physical conditions remaining constant, that's how we state Ohm's law. But if those conditions itself change, then Ohm's law will not be valid. To understand this, let us take a device like a conductor. Now this conductor will have atoms and molecules. We assume that it has some atoms about its mean position. I'm just drawing few atoms. I'm just drawing a rough diagram of atoms, not to be scaled and not to be understand what device it is. It's a rough diagram here. Now in every material or in all the materials, the atoms or the constituents like ions or molecules will vibrate about their mean position. Now this vibration is a function of temperature, which means as temperature increases, there will be more and more vibrations. Now imagine a case where the temperature of the material was around 300 Kelvin and temperature changes from 300 Kelvin to say 800 Kelvin. Since temperature is increased, the atoms assumed here will have more vibration. So an atom which is vibrating between these two ends will now vibrate to a further distance, or it will have a bigger amplitude now. Now since the atoms are vibrating more vigorously, then the electron, think of a single electron, then a given electron will have more collisions, because more distance the atoms cover, it will have more collisions, which means as temperature increases, resistance also will increase, or vice versa. When temperature decreases, resistance will decrease. But the assumption in Ohm's law is that we wrote V is proportional to I, or we wrote V is equal to I into R, and this R, which was called as resistance, was a constant of proportionality, which means R should always be constant. But if T changes, that is if T increases or T decreases, R itself is changing. So in that case, Ohm's law is not valid. We can use same argument even for other physical parameters also. So whenever other conditions changes, even then Ohm's law is not valid. The third point is Ohm's law is not applicable to semiconductors. Again, the points 1 and 2 are interconnected. In fact, these are not two separate points. Interpret the point 3 from point 1 only, saying that if it is applicable only for metallic conductors, then something which is not metallic conductor will not be applicable there. There are many examples of it, like semiconductors, like ionic solutions, like alloys. There are many such examples. The reason that it is mentioned separately here is to understand the fact that there is a separate chapter where we will be doing only about semiconductors. Just to connect it with that topic, it's been mentioned here. Otherwise, 0.3 is nothing but it's an extension of 0.1 only. So these are the common limitations of Ohm's law.